Greetings once again, math students, and today we are going to be focusing on the angle-triangle similarity theorem. And essentially what the angle-angle similarity theorem says, that if you have two triangles that have two of the same angles, then those triangles are going to be similar. So we've been dealing a lot with similarity and congruence. And what happens is when you have a triangle that has two angles that are the same, those can be said to be similar. Now, a couple of things I do want to highlight before we get too deep into the lesson is how we notate that angles are the same. And if you'll notice, we have these two little half circles, these two little half circles here on each of the triangles. And this denotes that that angle is the same in both triangles. And the same with one marking. And we do them in order. So if you were going to add the other similarity point, it would be 3 of the marks rather than 1 or 2. So it says that all of these angles do match, and that means that the triangle is similar. Now, for it to be congruent, they would have to have the same side lengths and all of the different pieces matching. However, with similarity, you can tell that if two of the angles match, they will be the same. Now, the other thing I want to point out is the important note here that says that remember that vertical angles are congruent. So this is important because you have to remember what a vertical angle is. So let's take a look. Vertical angles are angles that are formed by a shared vertex. Or in this case, we have this vertex that is shared. And these two angles, because of the way the vertex intersects, will be congruent. So if you have a vertical angle, the two or a shared vertex, those two vertical angles will be congruent. And that's important as we go through this lesson. So let's take a look at determining whether or not triangles are similar. So here we have two triangles. So we've got two triangles here, and our goal is to determine whether or not the triangles are similar. So using the angle-angle theory, we have to make sure that these two triangles have two matching angles. Well, now right off the bat, you see we can identify two right here. Both of them have measures of 61 degrees. So we can say right now that these two angles are the same. So of our angle-angle similarities, we have one of them already done. Now the trick then is to see if there is another angle that will match. And we don't have all three angles measured yet. We have in the larger triangle, we have 67 degrees. And in the smaller triangle, we have 52 degrees. So let's take a look then and see if we can find this third angle. So as you know, a triangle is going to equal 180 degrees total. So we know that 61 plus 52 is going to equal 113. And in that case, we know that this final angle here will be the remainder, or 180 minus 113, or 67 degrees. So we know this angle is 67 degrees. And if we look over at our larger triangle, we have a 67 degree angle and a 67 degree angle. So we know that these two triangles are similar. So we say, yes, they are similar. And then we are asked to explain, and this is where you have to use your habits of mind to use your mathematical reasoning. So the explanation is, quite simply, they have two matching angles. And so if they have two matching angles, we know that it is an angle-angle similarity. So looking at another example, we've got two triangles joined by a common vertex, and we have three different angle measures. We have a 75-degree angle, and an 82-degree angle, and a 25-degree angle. So the question is, are these triangles similar? And we need to explain. Well, first, as we talked about at the beginning, as we reminded about vertical angles, we can tell that these two angles share a common vertex. So we know that these two angles are indeed similar. So we've got two angles that are similar, one on each triangle. So we've got one part of the angle-angle similarity. And now we need to decide if it does fit the similarity model. So again, triangles are 180 degrees. So if we have a 75-degree angle and we have a 25-degree angle, that's 100 degrees, so that we know our remaining angle then would be the difference between 100 or 180 and 100. So this final angle is going to be 80 degrees. Now from here, we can take a look at the other triangle, and you can either do the math to figure out all three of the angles, or you can recognize that if you add 82 and 25, you end up with 107, which is not going to allow this angle to be the correct measurement. So it would not fit the angle-angle similarity. So in this case, when we go to answer, we say, no, they are not similar. And again, we are asked to explain, and the reason why is because they only have one matching angle. And that way we both answered and explained our rationale for how these two triangles fit the angle-angle similarity. Now our final example is a little bit different. You actually have two triangles here, one inscribed inside of another one. And we say a triangle is inscribed when one is inside the other. So you see the larger triangle that runs along the outside, but the inside triangle actually has many of the same features and is here on the inside. So in this case, we're looking for our angle-angle similarity. Well, starting off again, we can match two immediately when we see that there is a 90-degree angle or a right angle in both of the triangles. So now what we look for is we're looking for whether or not these meet the similarity model for angle-angle similarity. But you'll notice we don't have any of the angle measures. We don't know what this angle is, we don't know what this angle is, and we don't know what this angle is. So how then are we supposed to tell whether or not these triangles are similar? Well, the answer is pretty simple when you start to think about, once again, our rules about vertical angles. Now, when we talked in the last example, the vertical angle actually went away, creating two different triangles. But again, you actually have a shared vertex at point A. Now, point A creates an angle for both the smaller triangle and the larger triangle. And since point A is shared by both triangles, and since there's a 90-degree in both triangles, we can say that these triangles are similar. So yes, they are similar because they have two congruent, and as we know, congruent means same. They have two congruent angles. And that is how you work through your angle-angle similarity.